This is the ROS Developers Podcast, episode 70.
The ROS Developers Podcast, the ROS Developers. The ROS Developers Podcast, the ROS Developers.
Hello, ROS developers, and welcome to the ROS Developers Podcast, the podcast that gives you insights from the experts about how to program your robots with ROS. This is Ricardo Tellez from The Construct, and today I would like to dedicate this episode to all of you who have been trying to make work Python 3 with ROS. You know that ROS Classics works at present only with Python 2.7. So what happens if you want to use Python 3 library with your ROS robot? That you have a mess and even cannot do it. Yes, that's what happened. So in case that you are interested to know how to do that, we did a live class some weeks ago, a ROS Developers live class on our YouTube channel, where we were showing a method to achieve these mixing Python 3 libraries with ROS programs. It was super interesting, and I will put a link to it into the show notes. Then, let's go for the subject of today. Today we are going to chat with a person who is behind the Hub for Robots. Did you heard the Git Hub? No, I meant the Hub of Robots. So what is that? What is that interesting thing about the Hub of Robots? So you are going to learn in a minute. But before going into that, let me remind you about our ROS Online Academy, the academy that is called the Robot Ignite Academy, which contains a ROS learning path for beginners. We start by teaching you Linux and Python for robotics, and then we continue teaching you all the basic ROS concepts required to become a master of ROS, actually to become a ROS developer. So if you are interested to follow this path and become a ROS developer, check our online academy in the link that I will put at the show notes. Okay, so now it's my pleasure to introduce you Brandon DeHart. Brandon got his PhD on gate metrics for robotic pipets last year, and at present he is the engineering manager of the Robo Hub at the University of Waterloo. And he's also a sessional instructor at that same university. So the question is, what does it mean, this Robo Hub? What is Robo Hub? What is this sessional instructor at that facility? Actually, I don't know, but I'm sure that Brandon is going to explain us what is all that. So welcome to the podcast, Brandon.
Thank you for having me, Ricardo.
My pleasure. Finally, we managed to find the time to record this because we have been delayed. I have even had to change my introduction some seconds before, because it was already outdated.
Yep.
Okay, but here finally we are. And then the first question that the audience may be thinking about is, what is this Robo Hub?
So the Robo Hub is effectively a space, a set of researchers, equipment, etc., where we enable all of the connections between collaboration and robotics. So whether that's robots that work with people, whether it's robots working with other robots, whether it's trying to get the people that do robotics to work together. Don't tell them, but trying to get the professors to work together is the hardest one. But really just kind of enabling all of those various connections so that we can be enhancer as a multiplier effect on work that people are already doing.
Okay.
And one of the big things is we don't have any robots that have to live in a cage.
Oh, what do you mean that doesn't have to live in a cage?
So we don't work with kind of classic industrial robots, industrial robot arms, manufacturing arms. That kind of you can't touch them. All of our robots you can touch while they're in operation, and it's safe.
Okay, but then this is not a virtual space for that collaboration, but it is a physical space at the University of Waterloo.
Yes, so it's basically, we have a 10 meter cube effectively of space at the University of Waterloo, right in the heart of the new engineering building, Engineering 7. And the front wall is entirely windows, and pieces of the side walls are also windows. So actually from the atrium, you can look into this terrarium space effectively. It's like a robot fishbowl, and see what the researchers are working on. You can see the robots that are in there. You can see experiments running, things like that. But if we do need to do confidential work, if we do need to do anything like that, we can actually turn the windows off. They're electrochemical windows, so we can electrically kind of blank out the windows effectively.
Yeah, like the sunglasses effect. Something.
Yeah, similar thing.
Okay, and then you mentioned also that it's a safe space, so that the robots are not in a cage. And so how do you achieve to have a safe robot? Because that's very difficult. You cannot, especially if it is with people that are doing research, so they can do the most strange things and most stupid things. So how can you ensure that this is safe?
Yeah, so one of the things that we're working on, and we're working with kind of regulators and things to figure this out, is what mechanically you need, what electrically you need, what on the kind of firmware, low-level software embedded side you need in order to say this is a safe robot to work with. So whether that is for an articulated robot like an arm or a humanoid or a legged robot, torque sensors in all the joints, or enough of a direct drive that you can reliably compute the torque that is coming out so that you know that you can limit the torques and forces and things that you're applying on the world, applying on people. Mechanically, we're looking at pinch points. We're looking at kind of envelopes of operation where the robot can move quickly in this area, but slowly over here. We're also looking at the perception side of things. So laser scanners, 3D video, regular video. We're working with a couple of interesting startups in Waterloo, because Waterloo is kind of famous in Canada for creating a bunch of startups. A couple of them that are working on novel time of flight based sensors. We have a few novel infrared based sensors. So lots of different interesting things going on in terms of figuring out if people are nearby, figuring out how hard the robot is kind of pushing on the world, eliminating kind of the easy mechanical ones like pinch points and things like that. And putting all of that in a framework so that no matter what software is running on top, unless you actively disable it, which we strongly encourage you not to do, then the robot cannot hurt itself. It cannot perform an action that should hurt a person that is nearby, things like that.
Okay. But then you have to, in order to get a robot into your Robo Hub environment, then it has to comply all these requirements that you mentioned.
So generally when they come in, they have some of those things covered, and then internally we have a staff and a safety technician and things that kind of works with it and figures out what level of safe it is effectively and how much extra work we need to do to get it to the point where we want it generally usable. If it is not at that safety level, then you have to go through training as you would kind of anywhere else to say, okay, well, doing this with it is not safe, doing this with it isn't safe, quote unquote, Robo Hub safe. So you have to make sure there's no tour running if that happens, there's no other researchers nearby that haven't done the training, things like that. But the goal is that all of the robots that are operating in there, anybody who is on a tour could walk up and try to use, depending on what interface it has on it.
Okay. So super interesting and a very good point about pushing the safety of the for all the experimenters and all the people that is around there. And why the name of Robo Hub? So where does this name come from?
So the name Robo Hub actually came out when this new building was being put up. Okay. The funding for the Robo Hub itself and most of our kind of bigger robots was actually an investment. It was a grant from the federal and provincial government, so Ontario and Canada. It's the biggest grant they have given robotics in over a decade. So it obviously had to have a name associated with it, and the name that was used, that was kind of decided by committee, I will say, was the Robo Hub. But unfortunately, none of them were kind of heavily embedded in robotics and didn't know about robohub.org, the news aggregator and interview site and whatnot. And I've actually talked with Hallie Siegel, who was heavily involved with Robo Hub for a while, who's now at U of T running their robotics institute, about this exact thing. And it was kind of entertaining that there was stories popping up on robohub.org about this new thing, which was the Robo Hub at Waterloo. So
Okay.
yeah, it was entertaining.
Okay. Yeah. So for the audience, okay, don't confuse the robohub.org, which is this space about news on robotics that is on the internet. We know because it's been there for many years, and then this Waterloo Robo Hub, which is this
Correct.
space for collaboration between robots, between people, researchers, and teachers. And then now that I mentioned this about the collaboration between all these people, so how can people be part of the Robo Hub? Is that something that is selected people only, or that anybody can apply based on a project, or how does it work?
So basically the way it works is we have kind of a core group of researchers who were originally on the grant. So they and their academic collaborators, industry collaborators, their students, etc., obviously are using the space and regularly use the space. Mm-hmm. We also have a number of collaborators on campus who have kind of joined after the grant came in, who then again, they and their collaborators and their students, etc., are using the space. And we've branched out to, I want to say, 4 of the 6 departments within engineering on campus and 3 other faculties. People from kind of across the board are using the space. And we were also working with a number of other Canadian institutions and international institutions to figure out a way so that it is remotely, whether it's kind of sending us code to run on the robots and provide kind of hardware experimental data, things like that. The goal is that because this was such a big investment from the Canadian federal and the Ontario provincial governments, we want to make sure it's at least a resource at the provincial and federal level for everybody kind of across the board. Mm-hmm. And then because academia in general is such an international endeavor, sorry, my kids are laughing in the background here.
Yeah, it's okay. We have recorded this during the coronavirus crisis, so we have the family at home, and also I had my family here at the beginning of the podcast, but now in the middle is okay, no problem.
No worries. But yeah, so because academia is such an international kind of endeavor, the goal is that we can get it to the point where effectively anybody who wants to and kind of can get through basically like a basic kind of training system, could actually remotely use the robots. They could send code, they could come visit and use the robots. Particularly, we have heard from many people that this is really beneficial for new professors, for smaller institutions, places where, we probably have close to $3 million worth of robots in our facility.
Wow.
So Canadian, so that's like 12 euros or $8 American. But
wow.
basically we have a lot of robots. And being able to share that with everybody, because obviously they're not all in use all the time, being able to share that with the rest of Canada, with the world, is kind of one of our goals, because that is what collaboration is all about. So we want to walk the talk, basically.
Okay, very good. And then which kind of robots do you have already?
Okay, so we have a Talos humanoid, full-size humanoid from PAL Robotics in Spain. We have a number of ClearPath robots, because ClearPath is actually a Waterloo startup that came out of the University of Waterloo, and a lot of my roommates from university actually founded ClearPath.
Wow.
So we have most of their wheeled platforms. We have 1 or 2 of each, right from the Jackal way up through the Warthog, the outdoor amphibious vehicle. We have a couple of Panda arms from Franca Emica in Germany. We have a Gen 3 and a couple of Gen 2 arms from Canova in Quebec, as well as their mobile manipulator platform, the MOVO. We have, let's see, we have a KUKA, the lightweight 14 arm. We have a WAM arm.
What about drones? Do you have drones?
Drones, yep. So we have 5 Q drones and a few Q bots from Quanzer, which is in Markham, which is part of Toronto, or attached to Toronto, I guess. And they actually come with a full autonomous kind of collaborative suite so that the ground vehicles and the drones can communicate with each other right out of the box. So you don't have to do a lot of that kind of initial setup aspect. And we also have a few outdoor platforms, mainly DJIs. We have, I believe, a Phantom and 2 or 3 Matrices right now. The Matrice 210s with the differential RTK GPS, so that we can get reasonably accurate idea of where they are in the world. And we also have a number of
and maybe
other kind of smaller ground platforms and arms and things.
And small humanoids, maybe, like now or something?
Yes.
Maybe?
We do have, I want to say 5 or 6 of the V6 nows, the latest ones that came out last year.
Which one? Sorry.
The V6.
Okay.
I don't know when I started playing with nows, I think they were on version 3.3, and that was about 10 years ago. They just came out with the version 6.
Oh, okay.
I want to say last year.
Okay.
So we have a number of those. It's the same one. It uses the same software platform as the Pepper and the Romeo, so they've kind of conglomerated all the software side. There's also, we have a number of labs that we're associated with on campus that also have a Pepper and Miros and some of the Robotnik platforms. A bunch of our arms have Robotique hands on them. We have a significant number of them. Most of them are listed on the website. So if you check uwaterloo.ca/robohub or robohub.uwaterloo.ca, I think they both go to the same place now. There's a Meet the Fleet button, and that will get you to a big, I hope up to date, but a big list of the robots that we've got in the space.
Okay, I will put a link into the show notes to that page so people can go and check it directly. And I was talking to you about the Now robots because I saw those Now robots on a video that is where you have been featured. It's a series in YouTube that is called The Age of AI. That is a documentary series which is narrated and actually starred by Robert Downey Jr., the Iron Man. So how was the experience about being there?
It was really interesting, actually. The full production was very much like a TV show. I don't think there's any kind of distinction anymore between a YouTube show versus a TV show versus a movie.
Yeah, it looked like that. Yeah.
Yeah, and it was really interesting. We talked mostly about we talked in general about the Robo Hub, but mostly we talked about the humanoids specifically. So the nows that we have and the Talos, the full-size robot, full-size humanoid. But we talked a bit also about mainly the collaborative arms, because those are the ones that are kind of closest to the kind of real-world adoption. Because the episode that we were in was primarily about whether or not AI and robots will kind of take jobs and things like that. And a lot of what we talked about, so they interviewed myself, they interviewed our humanoid specialist, Alexander Werner, and they also interviewed a few other people, though I think only Alex and my interviews actually made it into the episode. But particularly about the fact that we see collaborative robots as a productivity gain and a tool that will benefit and kind of help people to do their jobs better and faster, and allow people who currently can't do particular jobs for whatever reasons, whether it's accessibility or age or strength or dexterity, whatever it is, they could then do those jobs instead of doing something they potentially don't enjoy as much or whatever. It'll kind of enable them to do more tasks than currently kind of feasible.
Or task on top of that, so they can concentrate their effort in something with more value, for example.
Yeah, exactly.
Okay. So I encourage everyone to watch the documentary, and it's very interesting, the subject. I mean, if you are a ROS developer, Yeah, and you will see that it is very easy. I mean, the subject is, they are not explaining deep robotics concepts that they are using on the robots, but it's very interesting. It's interesting, how to say in English, is entertaining. It's very entertaining. It's very well done, and you can see some of the robots that they do have at Robo Hub. Okay, and then let me check my questions again, because I jumped from one place to another. So then, how do you mentioned about the people that can access to the Robo Hub, physically accessing, but that some other people can access also remotely. So how is it going to be managed, and is it that already available? Because if you already have this available, then it could be quite interesting in the current situation that we are suffering of the coronavirus. So what is the status of that, and what are your plans now in the coronavirus situation?
So unfortunately, we didn't get the remote connection set up before everything that's currently going on happened. Or we would all be able to continue our research and remotely log into all our robots in the lab. But effectively, the goal is to allow people, because we want to have that, and it kind of builds into that safety layer that I was talking about. Once we have the robots set up in such a way that they cannot break themselves, they cannot smash windows, hit tables, etc., then the software that's loaded on them, the higher level software and the directives that are coming through ROS, through MoveIt, through whatever it might be, cannot hurt the robot. They cannot hurt the robot's environment, and therefore there's no reason to restrict access to put code on the robots. So basically the idea is, and you can see a good example of an implementation of this at the Robotarium at Georgia Tech. You can actually they have a program for allowing anybody that wants to go through a little bit of a training program, and then you can remotely log into their swarm robots that they've got there and control them and all these things, because they have an underlying safety layer that makes it so the robots can't break, and when they get low on charge, they kind of disconnect from the network and go charge themselves and all things like that. So we want to kind of take that idea, that model, and bring it up to things like the Jackal robots that we have, or the Panda robots, things that either can plug themselves in. We can rig up a easy self-charging system, or we might have kind of hours where they're available, and say, okay, well, during these hours, these robots are available. You can book your times, things like that. One of the ways that we're going to enable that is by, and we're still working on kind of what this is going to look like, but you'll be able to basically become a member, quote unquote, of the Robo Hub. And as a member, then you have access to various services and things, one of which is going to be hooked into kind of the construct and your kind of excellent cloud-based training portal.
Thank you.
And part of that is going to be effectively like a virtual Robo Hub. And we're hoping to then connect that potentially directly, but if not, then indirectly, into this remote operation, remote programming interface.
Interface with the robot, okay.
Exactly. So then they can get into the physical robot.
Okay, and then I would say, if I have correctly understood, that the bottleneck at present is the development of the safety layer that still needs to be fully implemented and tested into the robot, and that's why at present sorry listeners, you cannot still apply for the Robo Hub, but stay tuned, because it's going to be in the next months,
yes,
let's say.
It is coming up.
It is coming up.
The other big issue is that the majority of our robots are currently in a back storage room right now, because nobody is allowed to be on campus right now. The university is fully shut down.
Completely. So you're not even a single person can go to a room or a lab or so.
So if at the moment, anybody who wants to go to campus has to have campus police and the provost personally sign an approval that they are allowed to be on campus to do whatever they're doing, which basically means the only people who are there are people who are working on, for example, the university is working on a nasal spray based vaccine for COVID-19. There's people working on developing ventilators. There's people, basically, if you're not working on the current situation,
the crisis.
you're not going to be on campus right now.
Okay. Damn it. Okay, well, it's a setback. It's a small setback, but we are going to recover. We are going to recover and keep pushing. I'm pretty sure. Okay, so I had a question here that is if you are the actual first robot lab that allows to do these kind of things, like connected to the robot remotely and cooperate. But I know now that the answer is no, because you already answered that. You mentioned that Georgia Tech also has some similar thing.
Yeah. So Georgia Tech basically has a platform of swarm robots, a table of swarm robots, effectively, that they have
small
set up
ones. You mean
small ones? Yeah. So basically, on camera, they move around on a 2D surface. They can make shapes, and you can do kind of whatever programming you might want for them. But effectively, they move around on a 2D surface. Okay. We will probably be the first ones.
Yeah, that's another level.
Set something up.
Robo Hub is
in 3D.
Yeah, exactly. Well, not only 3D, but multiple types of robots with many different different locomotion systems and actual actions that they can perform and so on. Impressive. So I'm eager to see it working and go and visit it. Okay. And then another question is, what about other research that you are doing already with the existing robots? So I saw some of it on the video that YouTube has published, but can you tell us?
Sorry, I didn't catch part of that.
Yeah, so which kind of research have you already started by using the robots that you already have? You were showing on this video of YouTube very interesting subjects about cooperation and so on.
Yeah, so basically in the Robo Hub, we kind of have 4 main pillars when it comes to the research side of things. It starts with control, kind of fundamental control, and mostly that is focused on either the control of groups of robots at the same time, remote control, so teleoperation types of things, and then the low-level control for some of our more advanced robots like Talos, for example. We work kind of right down to the fundamental level. For many of the other robots, though, that kind of low-level part is well solved. It's a reliable, consistent platform, something like the arms that we purchase that are a product, things like that. We don't work too much in the weeds on them, although we do enable our researchers to do that if they want to. We do have one of our main primary investigators who works primarily in low-level nonlinear geometric control and nonlinear control approaches. So he likes to get kind of right down to the bolts, effectively, when he's doing things, to remove a lot of those abstraction layers. But for the majority, the control side is less, it's more of the high-level control. And then above building on that, then we have some of the perception. And we work with a great lab on campus, which is the vision and image processing lab, as well as the pattern analysis and the machine intelligence labs. So we have a lot of different pieces, as well as the AI Institute as well on campus, that are doing a lot of the focused pieces. And the perception piece that we really work on in the Robo Hub, again, ties into this idea of collaboration where we want to do shared perception. So you have cameras on one robot and laser scanners on another one and cameras in the space. How do you take all that information and make it into one shared map? How do you figure out where the people are, how far away stuff is, navigation goals, all those kinds of things. So it's less about, is there a dog in this picture, and more about where is that relative to me? How does that work with the space, SLAM, all those kinds of things. So we work at kind of the second level of perception.
Okay.
And then building on the control and the perception, then we have the planning piece, obviously, where we have to figure out how things are moving, particularly when there's multiple robots involved, or robots and people. So figuring out where they move, how quickly, what they're doing, who's doing what, distribution of tasks, all those kinds of things at that planning level. And then building on all of that, the big umbrella that everything falls under is interaction.
Okay.
And we define interaction a little differently than most. We do still consider kind of the classic human-robot interaction piece, where the robot is doing its job and the human is interacting with it. But in the interaction part, we also are concerned about the interface to assign tasks and the interface to correct tasks. So when you're actually teaching the robot what you want it to do you have to be a full stack robotics software person? Ideally, no, because you want to be able to give this robot to someone who is doing a job and say, this is a tool, show it what task you want it to do, whether you're telling it with your voice, whether you're showing it with your hands, whether you physically grab it and move it to whatever you want to do.
Like Buster.
Yeah, exactly. Or even if it is a computer interface, is it a touch screen? Is it more of an app? Is it more of a video game interface, as opposed to here is an empty box, type code into it, right? Obviously, fundamentally, in the back end, there's a lot of that going on. And I think there's kind of a sliding scale of where that interface goes, depending on what you want to do and how complex the task is. But ideally, we want to get it to the point where effectively, particularly something like a collaborative robot arm, like a Panda or a Gen 3, you can literally buy it with no robotics experience and use it to make your job easier, faster, better by eliminating some of those dull, dirty, dangerous, boring tasks that you might do. Right? You bolt it to your desk and it helps you do X, but you don't have to be a robotics expert to do that.
Okay, so are we taking ROS out of the picture here?
I think the idea would be that ROS would be the abstraction layer.
Okay.
So effectively, the low-level piece, which isn't really using ROS at the moment anyways, is doing those tight loops, it's doing the safety checks, all of that kind of stuff. And then there would be ROS running, whether it's ROS 1 or ROS 2, depending, on the physical robot, maybe on the computer, probably not. But then the robot is effectively acting as something, much like, you buy a printer, it hooks up to your Wi-Fi, your computer talks to the printer, you don't have to know how to program a printer to use it. You have an interface, right?
Yes.
But the interface from the computer to the printer is different than what the printer talks and what the computer talks. And I think that's where ROS is going to be the key. ROS is basically going to be the glue that connects the interfaces to the physical hardware.
Okay.
And I think depending on how far ROS 2 can get, the modularity and capabilities of being able to have ROS 2 systems kind of self-announce onto a network, self-connect, and kind of advertise themselves effectively, means that not just full robot systems, but actually individual modules within those systems can do that. So then you can literally buy a kit of parts and say, oh, I need a laser scanner and a mobile base and an arm and a vacuum gripper. Plug them all in. They tell each other what they are. So then the robot itself can self-configure based on the ROS 2 piece. And then you can use that ROS connection, that interface out to a computer, a camera, a game controller, whatever it is, to then do that part. It's going to be the glue that connects all the things together, for sure.
Okay, it's a very, very interesting vision. And then on top of that glue, there will be this other interface that is part of your research, that it will remove this complexity from the user of the robot. I
think the idea would be to generate kind of abstraction layers almost.
Okay, but are you trying to abstract this to the programmers also, or only to the final users of the application? So in which location are you putting the developers?
So I think it's going to end up, I hope, and this is kind of where I see it going based on some of what I've looked at, but I think it's going to look a lot like the internet kind of framework does right now, where as a user of the internet, you don't have to know at all how the internet works. Right? As a user of a robot, you should not have to worry about how the robot works. So that's kind of that first layer of abstraction. And then the second one, you come in to those of us who kind of grew up on the slightly older version of the internet, where if you wanted to do anything reasonably productive, you needed to know how to do HTML and Flash and, log in directly to an email server instead of just clicking the buttons, right? So that's the kind of the second layer.
Okay.
And then the next one is, people who know JavaScript and CSS and all of the front end stuff that lives on a website about the back end. And then you have the back end folks who are still on the front end of the internet, but they're doing the back end of various websites and things. And then you have the folks who deal with actual hardware, who live in server land, who live in cloud, like all, so there's many, many layers of abstraction. And at every one of those layers, potentially you are writing code. But depending on what layer you're at, that kind of dictates, are you writing Python? Are you writing JavaScript? Are you writing C? Are you writing assembly? Right?
Yeah,
where
exactly.
the lower down you get, the more fundamental the commands get. When you're moving bits around and that's pretty much all you've got, then, it's all up from there, right?
Okay, yeah. And then at the final layer, not the final, before the final, that would be the blocks that you put here, then you connect the navigation system, as you mentioned, as a laser and so on. And then the final layer, that would be the robot itself, that it behaves to the user like itself. And that's okay, interesting. So any papers that you have or any writings related to that, I think is very interesting reflection about that. Do you have any?
I haven't. I've been very busy buying robots and running the Robo Hub the last kind of year or two.
Okay.
But,
just wanted to learn more about this vision and explanation. So if anybody in the audience knows about this vision of Brandon, about the different layers, and then maybe you can comment to that in the comments of the show notes and tell us about that. Maybe it's somebody has started to do research on these lines. Interesting.
Yeah. And I think one of the things, and I don't know if we've talked about this with anybody yet, but there's a big new grant that the federal government in Canada is putting out that we have started applying for, I guess. It's still kind of in progress.
Okay.
Where they're looking for kind of transformational change in the world. And they want people to put together kind of world-leading teams to generate this transformational change over the next 6-7 years. And we have put in a proposal, and we're working on kind of the second stage of the application process for doing one that's effectively robots at work. So whether it's home office or office building, a desk job, a manufacturing warehouse, whatever it is, but robots that are specifically articulated and collaborative. So it's safe for the person to work beside it, and it has a number of joints that don't just move its base around. Whether it's sitting on legs like a humanoid or a quadruped, or it's sitting on a mobile base like a mobile manipulator, or it's sitting just on a table or a stand or whatever. The goal is to figure out not just technically what the challenges are, which we've already been talking about, the safety side and the programming and the interface and all those things. So we want to figure that part out too. And we have a lot of kind of really good robotics people involved already internationally. But we also want to answer the questions of what policies need to go in place. What kind of laws are we going to need in various locations? Regulations, safety standards. How does ethics play into it? Is it a tool versus a coworker versus, what level of kind of regard do you have for this particular object being? Depends on how you want to define it, right?
Yeah.
So we're actively working on a very, very large research project that is going to hopefully answer this question among a lot of the socioeconomic and legal and policy and ethical questions that come along with what happens when robots enter the workforce.
Okay, yeah, that's super interesting point, and that's the direction that we are moving as society, and in the field of robotics. So definitely worth the grant, and eager to hear of the result of that research.
We will definitely be sharing, and our kind of our motto, I guess, our mission statement is that because of the aging workforce, because of kind of the lack of people who want to do a lot of these dull, dirty, dangerous, boring jobs, collaborative robots are going to enter the workforce, but that's only going to be a good thing if it's done well. Right? It's not going to be good for most people if it's not done in such a way that it considers, again, the ethical, moral, policy, socioeconomic, etc., changes that are going to go along with that.
Okay, let me ask you about ROS, something about ROS, because, I mean, so this is the ROS Developers Podcast, and we haven't said almost anything about ROS. So are your robots running ROS at the Robo Hub?
The vast majority of the robots are running ROS. There are very few that are not, and those that are not, we already have plans in place to put in ROS interfaces for them, because our goal is to effectively have a ROS multi-master network, if we stick with ROS 1, or figure out how to integrate ROS 1 and ROS 2 to get to the point where we effectively have one big ROS network for all the robots in the space.
So you would like to attack both versions of ROS, ROS 1 and ROS 2? Why
Yes.
is that? Why is that?
I think, I mean, there's a couple of elements to it. One of the big ones is the security side of things.
Okay.
Because we're on a university campus, because engineers at universities are well known for trying to hack and prank things, because we are a very visible, open space, we need to make sure that any of our robots, particularly before we get to the point where all of the robots in the space are at that safety level that I've been talking about, that nobody who is in the university network or sitting outside the lab or anything like that can interfere with communication, take over robots, things like that. And you don't really have that with ROS 1. There's no real way to do that because security is just not really a thing in ROS 1, right? So
if your Robo Hub is so innovative, then why have you considered just going into ROS 2 straight instead of having to support ROS 1 and ROS 2?
So the big question for us is whether it is worth investing time in bringing our existing ROS 1 robots up to ROS 2 when ROS 2 will happily interface with ROS 1. Because our big thing is within a given robot, whether you're using ROS 1 or ROS 2 for our purposes, because it's mainly the security aspect, and because they're pre-existing robots, is not really a big issue. The big issue is the security thing. So talking between kind of the lab servers, the lab hardware, and the robots themselves, any of the wireless communication, things like that, we're going to want to be ROS 2. And because ROS 2 supports ROS 1 robots, we don't have to do too much work to be able to have a mixed interface system, a mixed version system. But it means that if we have the ROS 2 network, then any robots that we buy or build, whether they're running ROS 1 or ROS 2, will work fine, and we'll have that security level going on for the actual communication side of things.
Okay.
Which can integrate ROS 1 robots without having to worry about it. Whereas if we had a ROS 1 multi-master network or something like that, which are all somewhat kludgy to begin with, we would have to do a lot of work to integrate something like a ROS 2 system.
Okay. I don't know how it works, this mixture of, I don't know, you probably know better than me, that is about the security, in terms of security, I mean, because if you have a network with a ROS 1 master, then if you get into the network, then you can get straight into the robot itself. But when you have a mixture network where there is a ROS 2, so you can figure out how to block this access to, even if you are in the network, you can block this access to the ROS 1 robot?
Yeah, so effectively the way that we are planning to do it is that within a robot, a given robot, the internal network will be ROS 1, there will be a local ROS master, and it will then talk to a ROS 2 node, again, physically on the robot.
Yeah, I see.
And then the ROS 2 node on the robot is what actually talks to the outside world.
Okay. So it's isolated.
If you like plug into the robot, then yes, you can pretty much do whatever you want. But that's where that, it's kind of like an onboard firewall.
It's like an internal network. which is an internal network that you cannot access from the outside, but you can go out. You can go out, but you cannot access from, like, for example, our computers. So if I have my computer in a network that is a shared Wi-Fi, then not everybody can connect to my local computer. Okay.
Exactly.
Okay, that's a very interesting idea about mixing ROS 1 with ROS 2. It's super interesting. And then let me ask you a final question. So, what is the role of simulations in all these Robo Hub? Are you planning to use them? Have they any importance, or are you focusing on the physical robots only?
So a big part of our focus is on the physical robots because we have the capacity, we have the capability to do that and share that.
That's just very strong.
Currently, that seems like less of a strength since nobody can actually get to our robots right now. They're all locked in a cupboard.
That is true.
Because of the coronavirus.
That is true.
But yeah,
this will pass. This will pass.
Yeah, and we're working with kind of the insurance and legal folks on campus to figure out how we can do effectively like a robot library where we can actually loan the robots that we have to grad students. We actually have about 4 or 5 robots that are already kind of out at grad students' houses so they can continue their research. Right. But we're trying to figure out how to do that for some of the bigger platforms right now. But barring that, and in parallel with that, simulation is actually a big part of what we do because we want to make sure we are at a university and a lot of what we do is the training side of things. And part of training is being able to test things without really any consequences. And if you want to do that in robotics, simulation is the way to do it.
Yeah.
For some things, particularly for things like arms mounted on tables, for mobile manipulators, for anything that's kind of sitting on wheels, it's not at risk of falling over, things like that. Simulation is great, and it is a very close analogy, I guess, to the real world. You can do a lot of the code, you can write your ROS stuff, and one of the reasons why ROS is so helpful is you can kind of write all your control code, you can write your higher level code, you can write your navigation and all of that, and then it hooks through a ROS interface to the simulated robot. And then as soon as you have the hardware robot, that interface just points in a different direction, right?
Exactly. Doesn't care. Yeah.
So that's really helpful for a lot of our grad students, a lot of our undergrads even that we're working with. And folks that are kind of visiting professors, visiting from industry, anything like that, where they say, okay, well, this is the thing I want to do. And we can basically tell them like, oh, well, you can do all of that with a simulated robot and it will get close to what the real world result is going to be without any hardware. You don't need to invest in hardware. You don't have to have that capital cost, all those things. And one of the things that I think the Robo Hub is going to provide a lot to smaller labs, younger faculty, both on campus and elsewhere, and industry, is the ability to make the connection and figure out that transition from working on the software side, where we would be supporting them and things on there, come in and try it on hardware that we already have, and then say, oh, yes, this is exactly what we need. We'll buy, in the case of a small faculty member, 1, in the case of industry, 1,000. But they can try something, make sure that it makes sense and it works, and they say, okay, yeah, no, we're going to make that transitional leap into the collaborative robotics side. So
great. So that's a business model for your
big part of it, for sure.
Okay. Great. Okay. So I also believe that simulation has a very big role in the development of robotics and applications of robotics. It's not the final step, but is a very important one in the whole sequence. Okay. So then, that's all that I have to ask you here for today. Thank you very much for being here, and I wish that in the next months, so you are going to speed up the development, and then this coronavirus finishes, we can go, we can leave our homes and then keep doing all this work. So best of wishes for your Robo Hub.
It's been fun.
Okay. So thank you very much, Brandon. And then before we finish, then I would like to remind you, to all of you, to the listeners, that we would like to have a 10x increase in the number of listeners. So how can we achieve that? only with your help. People that are listening there, ROS developers out there, if you like the podcast, please help us reach that goal. And that is all for today. So please leave us a review in iTunes telling us what you think about the podcast and what you would like to have. Thank you very much for your 5 stars in iTunes. See you next week with a new lesson from the experts. And until then, keep pushing your ROS learning.